So over here, I've given you two matrices, matrix A and matrix B. And I've given you that the product of these matrices, A times B, is equal to C. So assuming that this product exists, because it's not necessarily true that it exists in every scenario, I want you to try and find Cij, where I is equal to 1 and j is equal to 1. Now, you might be wondering why I didn't just write C11. And while I could, the point of this video is to try and derive the formal definition of matrix multiplication, which a lot of people have a little bit of trouble on. So I think it's better that I leave Cij in terms of the variables I and j, so we can arrive at a general definition. So go ahead, pause the video, give this matrix multiplication a shot, come back and see me solve the problem. Also, if you don't know how to multiply matrices, I highly recommend that you check out the video where I teach you how to do that, because this would be pretty much impossible for you to understand if you don't know how to multiply matrices. The video should appear in the top right corner of your screen now, where I go over multiplying matrices. So go ahead, watch that video, come back here, and then just give this problem a shot if you fall into that camp. Okay, so let's go ahead and get into the video.
So before watching this video, you should know that I plan to make videos covering the entire undergraduate linear algebra curriculum. So make sure that you subscribe to my channel and turn notifications on, and you'll know when I post a new video that will correspond with the concepts you're covering in class. Also, I plan on making review videos that cover these topics at a faster pace. Check my channel if I've released those already, because that will be useful to you if you already know this concept and you don't have to sit around with a more in-depth explanation. And you should get the content across faster. Okay, cool. With that, let's get back into the video.
So recall that to multiply two matrices, all you have to do is take every single entry in a row of the first matrix, multiplied by every single entry in the column of the second matrix, and add them up. So to get Cij, which is what I asked you to find at the beginning of this video, all you have to do is take, well, A11 multiplied by B11, added to A12 multiplied by B21, added to A13 multiplied by B31, A13 multiplied by B31, and then keep doing this for every single entry in that row of A and that column of B, so the first row and first column here, until you get the last entry, which here I kept as some entry in the nth column of A and some entry in the nth row of B. So A1n and Bn1. So this is what Cij is. This is the quantity that I asked you to find. So we can manipulate this slightly in order to get the formal definition of matrix multiplication. In fact, we're very, very close right now. So the first thing I want to do is take out the fact that we're dealing with a specific row. So let's not deal with the first row and first column anymore. Let's just deal with the ith row and jth column, just some general column in both matrices. So what I mean by that is let's ignore this part for now, because that'll help us get a little bit closer to the general definition of matrix multiplication. So let's just go ahead and see what that would look like. We'd still have Cij, because once again, we're dealing with the ith row and jth column. However, instead of specifically dealing with the first row in matrix A, we'll deal with the ith row. And instead of dealing with the first column in matrix B, we'll deal with the jth column. So we'll have B1j. I hope that makes sense to you, because we're multiplying all the entries in the row of matrix A by all the entries in the column of matrix B. So in A we have the ith row, and in B we have the jth column. Let me just write a better j than that, because that looks like a u almost. Okay, so, and it's the exact same thing all over again, except instead of 1 we have an I here. So we'll have AI2 plus B2j plus AI3 plus times B3j, plus, and then all the way up to AIN times BNJ. And that's, again, is the last entry in matrix A and matrix B. Let me try doing a neater job at that. So AIN and BNJ. So once again, we're in the ith row of A and jth column of B. And I want you to notice something. Here, it's like predetermined by this definition of matrix multiplication that the number of rows of matrix B is equal to the number of columns of matrix A. We have n columns of A and n rows of B. Now, the reason that this makes sense is because, like I said in the video where I taught you matrix multiplication, for the product to exist in the first place, we need the number of rows of the second matrix to equal the number of columns of the first matrix. So the number of columns of matrix A have to equal the number of rows of matrix B for this matrix multiplication to exist. That should make sense to you intuitively as well, because we need one entry in the row of A and one entry in the column of B for this Cij to exist in the first place. For this one right here, we need one entry in B. For this one right here, we need one entry in B. And that's the only way we can multiply two matrices. So the only way that the product between two matrices exists is if we have one entry. For every one entry in the row of A, we have one entry in the column of B that we're multiplying with. So that's just a few different ways of looking at it. Now we can go ahead and move on to the general definition of matrix multiplication, because we're pretty much done here. If you've already seen the formal definition of matrix multiplication, you know that this is already what we're looking at. But we can go ahead and put this in summation notation to finish off the deal. Okay, so here's the general definition. We get that n is equal to 1 all the way to k of this sum right here. We'll get A, I, N times B and J. And this is equal to Cij, the general term. So this is the formal definition of matrix multiplication. And the reason I want to dedicate a video to this is just show you the steps that you would take in order to arrive at this formal definition, and show you that it really just corresponds to the definition that I taught you intuitively in the video I taught you about matrix multiplication. It's just a more formal way of representing it using summation notation. It's a little bit cramped right here, so I'll rewrite it up here. Cij is equal to the sum from n is equal to 1 to k of A, I, N multiplied by B and J.
I just wanted to thank you for sticking around until the end of the video. It really does mean a lot to me. If you have any questions, you're welcome to leave a comment, and I'll try and respond as quickly as possible. On screen, you should see a link to a playlist containing every single one of my individual linear algebra videos that I made so far, and the ones that I would have made in the future, so go ahead and check that out. You should also see my last video, so if you're a little bit confused in this one and want to see the previous concept, you can click on that. And finally, you should see a subscribe button, and if you want to be notified for my future videos, and also wanted to tell me that you enjoyed this video, you can do that. Okay, cool. So that's it, and until next time, bye!